Okay. The summary of rate of change and slope. So that's rate of change and slope are exactly the same thing. They're identical. Rate of change is what we talk about when we're talking about like a real world situation, like when you're driving down the road. Your rate of change is your speed. Slope is what we talk about when we're just talking about like algebra type stuff. The slope of a line on a graph. Okay? Or if you were to graph that real world situation, you could talk about the slope of the line that you graphed. But it's always the slope of the line that you graph. So, the summary, M stands for what? Slope. M equals slope. Another way that we could say slope is M equals, I'll get there, the change in y divided by the change in x. How much does y change divided by how much does x change in that same time span? We also have, somebody already said it, rise over run. And then the last thing we learned yesterday was y2 minus y1 over x2 minus x1. All of those things say the exact same thing. The slope of a line, the rate of change. Okay? We're going to use each of these at different times. When do we use rise over run? On a graph. When do we use y2 minus y1 over x2 minus x1? Use when you're given ordered pairs. When do we use change in y divided by change in x? Tables, that's right. Use with tables. Okay? So now you know how to calculate the slope given a table, given a graph, or just given ordered pairs. You can find the slope. We have several types of slopes, and I kind of hinted at this yesterday. There's positive slopes, there's negative slopes, there's zero slopes, and there's undefined slopes. If you think about, where have you heard the word slope before? Like aside from math class, where? Ski slope. On a ski slope, do you go anywhere if it's flat? No. You only go somewhere if the slope is down, right? And do you go faster if it's a steeper slope, or do you go slower if it's a steeper slope? Okay, so you kind of already have an idea of slope. If it's a steep slope, you're going to see a steep line, like more like a cliff than just a gentle hill. Okay? If it's a shallow slope, you'll see just a gentle little drop from one end to the other. Okay? So you can say steep or shallow. But we also have positive and negative slopes. If you have a positive slope, like I said last time, what is the line doing? Going up as we move from left to right. Just like reading a book. If you read this graph like reading a book, you will see that this line is going up from left to right. And that's because we have a positive slope, okay? In order to go from this point to this point, we got to go up, which is positive. We got to go right, which is positive. Positive divided by positive is positive. To have a negative slope, the line will go down as we read this from left to right, okay? The line is falling from left to right. Would you say that this is steeper than this? Yes or no? No, it's not. Even though this one's positive and this one's negative, if we were skiing, we wouldn't go nearly as fast on this one as we would on this one, okay? So this one's steeper. Make sense? Okay. For a negative slope, we're having to go down first, and then we're going to the right. Down is negative, and then right is positive. And it doesn't matter to me which you do first. If you want to go up always, and then decide if you're going left or right, that's fine. If you want to go up or down first always, and then go to the right, That's fine. For me, my preference is I usually pick a point on the left, and then I either go up or down. If I go up, I'm going to wind up with a positive slope. If I go down, I'm winding up with a negative slope, because then I'm always going to the right, and to the right is positive. Okay? It's up to you, however you want to do it. But like I said yesterday, try to always do it the same way, and that will minimize your mistakes. Okay, zero slope. What's another word for how that line looks? Horizontal. It's a horizontal line. Picture the floor. If we were to go skiing on our floor, would we go anywhere? No. If you were to put a marble on the floor, would it roll away? No. Unless you lived in one of the houses that I lived in when I was in college, and then it would roll to the downstairs completely. From upstairs all the way to the downstairs, because the house was so terrible. But generally, your floor is flat and it won't roll, okay? There is no slope to that floor. No slope means zero slope. This is a horizontal line, zero slope. You could also say no slope. And we're also going to say horizontal. Just like the horizon. Horizon's flat, where the ground meets the sky. Same thing here. Okay? If you have an undefined slope, then that means you have division by zero. Like we had that 11 divided by 0 on that last problem that we did last time. That was an undefined slope. And what kind of line do we wind up with? It's a vertical line. Okay? Thank you for not saying a straight line. It's a vertical line. Is this a function? Why not? We do have division by 0, which doesn't work. But when we're looking at a graph, if we want to figure out if something's a function or not, we use the vertical line test. If I pass a vertical line over this, the entire line touches my vertical line because this line is vertical. This is not a function. Is this one a function? Yes, this one passes the vertical line test. All of these lines will pass the vertical line test except for this one right here. That's not a function. A good way to check your answers is by looking at the sign of your slope. Always do that. If I give you some sort of equation, and you guys will soon learn how to look at an equation and know what the slope is. If I give you some sort of equation and you see that the slope is negative, which one of these, 1, 2, 3, or 4, should our graph look most like? The second one. If our slope is negative, we should have a line that goes down from left to right. If our slope is positive, we should have a line that goes up from left to right. And it takes literally 3/100ths of a second for you to see that and know it instantly. Okay? And then when you make your graph, that's one way you can check to make sure that you at least have that correct. Nothing kills me more than when somebody gives me a slope that's positive and I see a line that's going down from left to right, because it just tells me you're not thinking. Okay? Okay. Now we've done everything we need to do in this section. You've learned everything. These two problems right here kind of take it one step farther, and they really apply some algebra. It says find the value of r so that the line that goes through 1, 4 and -5, comma r. Here's that r right here. We want that line to have a slope of 1/3. In order to do a problem like this, we need to use the slope equation that we learned and then solve for r. That's the tricky part. So, my slope equation is m equals y2 minus y1 over x2 minus x1. Now, usually when we use the slope equation, we're solving for m. We're plugging in two ordered pairs, and that'll give us the slope. But here, they gave me the slope. It's 1/3. So I'm going to put 1/3 in for m equals. Now I got to figure out what y2 and y1 are. So I can label this x1, y1, x2, y2. So what's y2? R. Minus, what's y1? 4. Divided by, what's x2? -5. Minus, and now go looking for x1, which is 1. So that's the setup for that problem. Now we got to figure out a way to solve for r. To do that, can I combine these here? No. Can I combine these here? Yes. So I can do that. 1/3 equals r minus 4 divided by what? -6. Now the question is, how in the world am I going to solve for r? Go ahead. Yeah, there's two ways you can do this. With that r up top, you can just get rid of the denominator here by multiplying both sides by -6. And then r minus 4 will be by itself on the right-hand side. The other way is to think, okay, this is a fraction, I got an equal sign here. What I have here is actually a proportion. And one way to solve proportions is to cross-multiply. So we could cross-multiply here instead. Okay? If the r is on the bottom, you're going to have to cross-multiply. In this case, it's on the top. So we'll do what you said. We'll multiply both sides by -6, and that will get rid of the denominator for me on the right-hand side. What's -6 times 1/3? It's negative still, 6/3, which reduces to -2. So I don't have any room, I'll go up here. -2 equals, what happens here? These two guys right here are gone, and I'm just left with the r minus 4. That was the whole point of multiplying by that denominator. It disappears. So you're left with r minus 4. And now we're back in like chapter 1, chapter 2. What do we do? Add 4 to both sides. And I get r equals 2. So find the value of r so that the line through 1, 4 and -5, r has a slope of 1/3. I'm saying r is 2. If r is 2, then it gives me a slope of 1/3. Okay? Let's check that to see if it worked. Okay, what were my 2 points? 1, 4, so right there. And what was my other point? -5, 2. We found 2. So I go -5, 2 right there. Okay? Now I want to calculate the slope. And we want the slope to be what? 1/3. So if I go from here, I go up 2, and then I go right 1, 2, 3, 4, 5, 6. I went up 2, right 6. So my slope is 2, 6, which is 1/3. So it worked. Okay? The math works. So trust the math. Probably the hardest part is right here. After that, this part right here shouldn't be too tough. So let's see if we can do the last one. We can do it together. What should we do? Sure, start with the slope formula. M equals y2 minus y1 over x2 minus x1. Before I do that, I might label stuff. So I'll call this x1, y1, x2, y2. And then what's this number right here? Which is what letter? M. Okay, so now we know what all this stuff is. Let's fill it in. What do I write? -5 for m equals y2 is -4 minus y1 is 6 divided by x2 is r minus, and then x1 is -2, so minus -2. Lots going on here, lots of negative signs, so be careful. Now what? I want to simplify this a little bit before I cross multiply. What's -4 minus 6? It's -10. Okay, so I have -5 equals, the numerator here becomes -10. What does the denominator become? r plus 2. We change here. We can't combine these, so we just write r plus 2. Now what? Okay, cross multiply. What is this negative 5 here actually if I'm about to cross multiply? Yeah, negative 5. We'll put that over 1, and that'll make it easier for me to cross multiply. I have to cross multiply here because of the fact that that r is in the denominator. I can't sneak out of it like I did up here. So we're going to cross multiply. We'll go 1 times negative 10 and negative 5 times r plus 2. So what's 1 times negative 10? Negative 10 equals negative 5 times r plus 2. So I'm going to write that down. Negative 5 times r plus 2. You want to distribute? We can do that. Negative 10 equals what? Minus 10. Now what? Okay, we got to get rid of this minus 10 here to get r by itself, so plus 10, plus 10. What do we get? 0 equals negative 5r. Now freak out because there's a 0 that just showed up. No? Divide both sides by negative 5. That gives me what on the right? On the right? R equals 0 divided by anything besides 0 is 0. So r equals 0. That's the answer I got. Okay? You want to check it? Yeah, let's check it. So we have, help me with the ordered pairs. Negative 2, 6. Okay, right there. And then 0, negative 4. And what's the slope that we're looking for? Negative 5. So for me, I always start on the left point. Here's my left point right here. And I got to go which way? Rise first. So I'm going down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I went down 10, and then I got to go right 2. So going down 10 is what? Negative 10 over positive 2, which reduces down to negative 5, which is what I wanted. So I know that I'm right. I have r equals 0 is correct.